Hi everybody, hopefully you had a great weekend. Happy Monday. And this is your first of two review lessons. For this first lesson, we're just going to do some mixed problems between SOHCAHTOA, sine law, and cosine law just to get you back in the swing of things. Make sure you have your calculator with you, and you might want to have your formulas in front of you. If you don't, that's okay. We're going to re-go over all of them. Our learning goals for this first review lesson: decide which tool to use based on the type of triangle, and we are going to then use one of SOHCAHTOA, sine law, or cosine law to solve word problems. So we're just going to do word problems. Those are the best kind of problems to review because we have to pull out the information, draw the triangle, and then use those tools, or one of those three tools, to solve a triangle. The first thing here is just a summary of tools. You don't really have to copy this down. This is just to go over everything with you again. So use SOHCAHTOA, or Pythagorean theorem, if the problem involves a right triangle, meaning it has a 90-degree angle. Use the sine law with two angles and a side, or two sides and an opposite angle. Really, that just means, or when we did it together, you have a complete letter. So I'm just going to summarize that by writing a complete letter. And you use the cosine law with two sides and a contained angle, or it's the only one you can use if you have three sides with no angle. Or when we summarized this in previous lessons, no complete letter. And at any point, do not forget that there are 180 degrees in a triangle. So that's a summary of all of the tools that you're going to have to use for your test. So our first example, and there's only three, so you can pause it, take a minute to copy it down, and then come back to the solution. Or you could just follow along, draw the triangle and the solution, don't worry about writing the actual word problem, and then you could just say, leave a note to yourself, refer to the video, or refer to D2L if you really need to see. So a 10-meter ladder leans up against a wall, 9 meters above the ground. Safety standards mandate that the angle of elevation must be between 70 and 80 degrees. We want to know, is the ladder safe to climb? So the hardest part about word problems is, in my opinion, making the triangle and getting that information out of the actual words. So I've kind of scaffolded this for you. I have a little bit of a picture there. So we got some kind of ladder. We have the ground, the ladder leaning up against a wall, and with his ladder, that's going to make a triangle. Unless I tell you otherwise, you are always going to assume that anything that meets the ground, could be a tree, could be a building, could be a wall, anything that is straight up and down, we're going to assume meets the ground at 90 degrees. So we can put that 90 in there. Now if we read the question kind of one part at a time, a 10-meter ladder. So my ladder right here, the length of my ladder is 10 meters. It says it leans up against a wall 9 meters above the ground. So if my ground is on the bottom, it's 9 meters above the ground. That means right here, this length straight up and down is 9 meters. Safety standards mandate that the angle of elevation must be between 70 and 80. Now we're going to use that information to actually answer the question, but the key there is angle of elevation. And you have to go back and remember that the angle of elevation always comes up off the ground. And the only angle we have coming up off the ground is this one. So up off the ground. I'm just going to call this X because that's the angle we're looking for. Since it has 90 degrees in it, That means we are going to use SOHCAHTOA. That's what we use for 90-degree triangles. In order to figure out which one of those to use, you have to label your sides with the words opposite, adjacent, and hypotenuse. The one across from the 90 is always the hypotenuse, so over here is the hypotenuse. And remember, this is my reference angle, the angle that I gave you. You can never use 90 as your reference angle. So since that's the angle we're looking for, that's our reference. Right across is opposite, right beside is adjacent. Next, get rid of whichever side gives you nothing. The only side that gives us nothing is the adjacent, so let's get rid of it. This is visual clutter. All that I'm left with is opposite and hypotenuse. Out of SO, CA, and TOA, the only one that has O and H in it is SO. What does the S stand for? Sine. And beside these, so beside your trig operators, sine, cos, and tan is always what you circled. In this case, x. And it goes in order. O, H, opposite over hypotenuse. 9/10. Don't forget, you're not going to type in sine of 9/10. Whenever you are looking for an angle, you are using the sine inverse or shift sine second function sine. And remember, that looks like x equals sine inverse bracket 9/10. Take out your calculator, make sure you are in degree mode, type in shift sine, open bracket, 9 divided by 10, close bracket, and let's say we'll go to 1 decimal place. I get 64.2 degrees. If you didn't get 64.2, try it again, and if not, maybe talk to Mr. Hack to make sure your calculator is in degree mode. Now, to answer the question, it says to be safe, it has to be between 70 and 80. Is 64.2 between 70 and 80? Hopefully you're shaking your head no. So any word problem gets a therefore statement. Therefore, the latter is not safe because it's not between 70 and 80 degrees. So there is a SOHCAHTOA review question. Example number 2. Again, you can pause the video if you want to copy down the question or just do the picture and the solution. A cable car stops partway over an 86-meter gorge. The cable makes an angle of depression of 57 at one end and 40 degrees at the other. How long is the cable that holds the car? And we want 1 decimal place. If you don't know what a gorge is, it's just like an opening, like think like Grand Canyon, but on a way smaller scale. So I'm going to make kind of Grand Canyon-esque kind of picture. So there's an opening. Let's say there's some water down here, doesn't really matter. And then cable cars going over top of it. So we have some cables that connect it at the top. And then we want to continue to make this triangle by just going straight across as our sight line. So once we have that kind of picture, we have our triangle. I don't see any way we can get a 90 in there, or that we can safely assume that there's a 90. So let's start going to pull out the information out of the question. So it says a cable car stops partway over an 86-meter gorge, meaning it's 86 meters wide. So that's that distance. The cable makes an angle of depression of 57 at one end and 40 at the other. Now you have to remember, Angle of depression goes down off the horizontal. So down off the sight line or down off the horizontal. So one is right there and the other is right there. It doesn't matter for a test which one's which, you get the same answer, but for the sake of the lesson, let's everyone label this 57 and this 40. And we want to know how long the cable is. So let's call this A and this B, because the cable technically consists of the length at A plus the length at B. Now let's label our triangle. So if that's small a, that's capital A, small b, capital B, and we'll call this capital, we'll call this capital C, we'll call this small c. So we don't have a 90, we don't have a 90 that we can assume is in there. So that means let's go to our little chart that we make. Fill in your information. I don't know A, I don't know B, I do know C. Capital A is 40. And capital B is 57. And capital C we don't know. So you're going to ask yourself, do you have a complete letter? And in this case, we definitely do not. So the next question you're going to ask yourself, do we have an easy way to get a complete letter? And hopefully you're thinking yes. If I have two angles, I can easily find out the third angle by remembering there is 180 degrees in a triangle. So if I do 180 minus 57 minus 40, so if we type in our calculator 180 minus 57 minus 40, we will get 83. And that means C is 83. Now, do we have a complete letter? Yes. Letter C is complete. And if we have a complete letter, that is our indicator to use sign law. So we do eventually have to find A and B and then add them together. So let's find A first. Sign law, looking for a side length. A over sine A, which in this case is 40, equals, and on the other side of the equal sign is the letter that you have complete. So 86 over sine 83. Get rid of that sine 40 by cross multiplying. A equals 86 sine 40 over sine 83. We want one decimal place. Type that in your calculator just like you see it. So 86 sine 40 divided by sine 83. And hit equals. And we get 55.7. Okay, so there's A. Now let's find B. And remember, since this isn't 90, we can't use Pythagorean theorem, so we're going to go back to sine law. So B over sine 57 equals, again, the letter you drew the box around. So that was C, 86 over sine 83. Cross multiply. B equals 86 sine 57 over sine 83. Type that in just like you see it. So 86 sine 57 divided by sine 83. One decimal place, I get 72.7 meters. Now we want to know the total length of the cable. So we have to add those two together. So if I want to do the total, so the total equals 55.7 plus 72.7, So use your calculator, 72.7 plus 55.7, and hopefully you get 128.4 meters. And then don't forget, therefore statement. I don't have much room left here on my slide, so I'm just going to write therefore and ... you fill in the rest. Something like therefore the total length of the cable is 128.4 meters. So that's a good example for sine law. It makes us do it twice, and we also had to do a 180 minus to get a third angle. Example 3, if you're going to copy it, pause it, otherwise just keep going. A sewer pipe runs underground along 4.8 kilometers of road. It is connected at one end by another pipe, 2.5, and makes an angle of 72 degrees with the first pipe. How long would another pipe need to be to connect both of those pipes? And what is the measure of the angle made by the connecting pipes? So start with A, and we'll make a picture. A sewer pipe, okay, 4.8 kilometers. It's connected at one end by another pipe, 2.5. So we'll say that's the 2.5. And makes an angle of 72 degrees with the first pipe. So 72 degrees. How long would another pipe need to be to connect those? So we want to know how long that is. So we'll call that x. Now, when deciding what tool to use, there's no 90s, so we can't use SOHCAHTOA. And we don't have a complete letter. Now, you can make the chart if you wanted to. If you don't want to make the chart, or if you're just looking visually, this is where we have two sides and an angle between them. Or another way to look at it, I would need to have my side with the matching angle, which I have for that, but then I would need to have this side with this matching angle, which I don't have, or I'd have to have this side with this matching angle, which again, I don't have that. If you're not comfortable thinking about that visually, you can make your chart and put some letters around, fill it in, and you'll realize that you can't use sine law. You don't have a complete letter. You don't have two opposite angles and side lengths that match. So if that's the case, you're going to use cosine law, which for side length would be x squared equals, since that's what we're looking for, the other two sides squared, so 4.8 squared plus 2.5 squared, minus 2 times 4.8 times 2.5 times cos 72. And cosine law is nice because you literally can type that in from that step, just like you see it. So everyone type in 4.8 squared plus 2.5 squared minus 2, and then in brackets 4.8 and 2.5 in brackets, cos 72. And to one decimal place, I get 21.9. And remember, that is not the length of the pipe. That's x squared, and to get rid of a squared, you got to square root. So if we square root 21.9, I get 4.7 kilometers when we round. So there's the answer to A. The answer to B, what is the measure of the angle made by the connecting pipes? So this time I'm looking for, we'll call this Y. So I'm looking for that angle. So if we're deciding whether to use sine law or cosine law, we could technically use sine law now because I have a complete letter. I know that I have 72 degrees, and I have the side across from it, which would be 4.7. I just calculated that. So we can use sine law. this time for an angle. So since I called that y, sine y over, now if that's capital Y, that would be small y, so over 4.8 equals the one that we have complete, which is x, so that will be angle x. So sine 72 over the side length we just calculated, which was 4.7. Then to get rid of that 4.8, cross multiply. Sine y equals 4.8 sine 72 over 4.7. Now remember, whenever you are finding an angle, you're not just going to type in sine of that, we're going to do sine inverse. So y equals sine inverse, and then in brackets, everything you have written there. Shift, sine, open bracket, 4.8 sine 72 divided by 4.7, close bracket, it equals, and to one decimal place, I get 76.2 degrees. And there is A and B answered. So we'll put some therefore statements in. So therefore, the connecting pipe would be, we got 4.7 kilometers long. And for part B, therefore, the angle of the connecting pipes is 76.2 degrees. So that's a good question because it makes us do cosine and sine law, and you can do multiple things within the same question. That's definitely okay. Just as long as there's a 90, you can use SOHCAHTOA. If there's no 90, you can't be mixing SOHCAHTOAs in there with sine laws and cosine laws. So hopefully that is a good kind of first review for everybody. You're going to work on section 3.5 of your workbook, and in fact, at some point before you write your test, you should be done all of chapter 3, all of trigonometry. I do have 2 achievement checks here for you. They would be very good practice for your test. Especially Mr. Hack knows a thing or two about squash, so he's the man to see about achievement check number 1. And then another one here for achievement check number 2. And again, you can ask Mr. Hack to check your answers, or you can send them to me in D2L, Asia, or via email, and I will get back to you. Have a good morning, and we'll be back with your final video lesson of 2020 later today.